It's me, Teacher Jeanne. In this lesson, you will learn about factoring sum or difference of two cubes, SOTC or DOTC. After going through this lesson, you are expected to factor the sum or difference of two cubes. What to know? Listed here are the perfect cubes that we need to master or memorize for our future lessons. When we cube a number or integer means we multiply by itself 3 times. So 1 cube is equal to 1, 2 cube is equal to 8, 3 cube is equal to 27, 4 cube is equal to 64, 5 cube is equal to 125, 6 cube is equal to 216, 7 cube is equal to 343, 8 cube is equal to 512, 9 cube is equal to 729, 10 cube is equal to 1000. 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000 are what we called perfect cubes. So here are the list of cube roots. Getting the cube root of a perfect cube considered the reverse process of multiplication. So let's have cube root of 1 equals 1, cube root of 8 equals 2, cube root of 27 equals 3, cube root of 64 equals 4, cube root of 125 equals 5, cube root of 216 equals 6, cube root of 343 equals 7, cube root of 512 equals 8, cube root of 729 equals 9, and for the last we have cube root of 1000 equals 10. We're done with the coefficients and constants. Now let's move on to the perfect cubes given the variable. So here, we multiply x 3 times by itself and it gives us x cubed. For x squared, it gives us x to the 6th. For x cubed, it gives us x to the 9th. For x to the 4th, it gives us x to the 12th. For x to the 5th, it gives us x to the 15th. Now to get the cube root of our perfect cubes, we simply keep the variable and divide the exponent by 3. So cube root of x cubed is equal to x. Cube root of x to the 6th equal to x squared. Cube root of x to the 9th is equal to x cubed. Cube root of x to the 12th is equal to x to the 4th. Cube root of x to the 15th is equal to x to the 5th. In the expression a cubed, 3 is the exponent. So if the exponents are 3, 6, 9, 12, 15, so on and so forth, or multiples of 3, they are considered perfect cubes. So in the given cube root of a cube, 3 is the index from the word cube. A is the radicand, and we have the radical sign. Cube root of a cube is equal to a to the power of 3 over 3, or a to the first, or just simply a. So therefore, cube root of a cube is equal to a. Next, given cube root of m to the 6th is equal to m to the 6th over 3. 6 is the exponent divided by the index 3. So simplify, it gives us m squared. So here, we need to recall the special product. Given the product of a binomial and a trinomial of the form, the quantity of a plus minus b times the quantity of a squared minus plus ab plus b squared. And that is equal to the sum or difference of two cubes. Now let's have the quantity of x plus y times the quantity of x squared minus xy plus y squared. And that is equal to cube the first term x cubed, cube the last term y cubed. Then if the binomial is plus, the operation of the product is also plus. And that is what we call the sum of two cubes or SOTC. Next, we have the quantity of x minus y times the quantity of x squared plus xy plus y squared. And that is equal to cube the first term, we have x cubed, cube the last term, we have y cubed. And if the binomial is minus, the product is also minus. And that is what we call difference of two cubes or DOTC. What's new? As I have said, factoring is the reverse of multiplication or getting the product. So factoring sum or difference of two cubes, that is equal to the product of a binomial and a trinomial of the form the quantity of a plus minus b times the quantity of a squared minus plus ab plus b squared. Now let's have the sum of two cubes given x cubed plus y cubed, and that is equal to the product of a binomial and a trinomial. So to get the binomial, we're going to get the cube root of x cubed, we have x, cube root of y cubed, we have y, then we keep the operation plus. Then for the trinomial, we're going to square the first term, x squared. The opposite of plus, we have minus. Multiply the first and the last, we have x times y. Then square the last term, we have y squared. Next, we have the difference of two cubes, given x cubed minus y cubed, and that is equal to the product of a binomial and a trinomial. So here we get the cube root of x cubed, we have x, cube root of y cubed, we have y. Then we keep the operation minus for the binomial. Then for the trinomial, we're going to square the first term, we have x squared. The opposite of minus is we have plus. Multiply the first and the last, we have x times y. Then square the last term, we have y squared. So as you can see, those are the product of a binomial and a trinomial. A polynomial is a sum or difference of two cubes if it satisfies these two conditions. First, it is a binomial. Second, each term is a cube. Now for the binomial factor, the first term is cube root of x cubed, so we get x. And the last term is cube root of y cubed, so we get y. Now for the trinomial factor, the first term is square of x, so we get x squared. For the middle term, we have the product of x and y, so we have xy. And for the last term is square of y, so we have y squared. Now let's talk about the operations or signs. Now for the binomial factor, we have s for the same signs. Then for the trinomial factor, we have the middle term, we have o for the opposite signs. And for the last term, we have ap for always positive. So some people use the acronym SOAP, same sign, opposite sign, always positive, to help keep track or remember of the signs. Now for you to understand, let's have the first activity. Determine whether these are sum or difference of two cubes. If yes, factor completely. So let's have the first one, 8x cubed minus 1. Now let's see if the given satisfies the two conditions. First, it is a binomial. So as you can see, it consists of two terms. That is yes. Second, each term is a cube. So 8x cubed is a perfect cube. 1 is also a perfect cube. So that is yes. So cube root of 8x cubed is equal to 2x. Cube root of 1 is equal to 1. So we can write the factored form as the product of a binomial and a trinomial. So for the first term, we have 2x. For the second term of the binomial factor, we have 1. Then we keep the operation minus. For the first term, we're going to square 2x. We have 4x squared. Then the opposite of minus is plus. Multiply the first and the last. 2x times 1, we have 2x. Then square the last term. 1 times 1, we have 1. So we have the quantity of 2x minus 1 times the quantity of 4x squared plus 2x plus 1. Now to check if your factor is correct, let's have the quantity of 2x minus 1 times the quantity of 4x squared plus 2x plus 1. We are going to cube the first term, we have quantity of 2x cubed. Then cube the second term, we have 1 cube. Then keep the sign or operation minus. So we have the product 8x cubed minus 1. The difference of two cubes or DOTC, so we got it correct. Another way is using distributive property. Given the quantity of 2x minus 1 times the quantity of 4x squared plus 2x plus 1. So we distribute 2x to the first term. We have 2x times the quantity of 4x squared. Distribute 2x to the second term. We have 2x times the quantity of 2x. Distribute 2x to the third term. 1, we have 2x times 1. And distribute negative 1 to the first term. For x squared, we have negative 1 times the quantity of 4x squared. Distribute negative 1 to the second term, 2x. We have negative 1 times 2x. Distribute negative 1 to the third term. 1, we have negative 1 times 1. Then simplify, we have 2x times the quantity of 4x squared, we have 8x cubed. 2x times the quantity of 2x, we have positive 4x squared. 2x times 1, we have positive 2x. Negative 1 times the quantity of 4x squared, we have negative 4x squared. Negative 1 times the quantity of 2x, we have negative 2x. Then we have negative 1 times 1 is we have negative 1. So 4x squared minus 4x squared is equal to 0. 2x minus 2x is equal to 0. And the remaining is 8x cubed minus 1. So we have the same answer. And you got it correct. For example number 2, we have x to the 6th, y to the 4th plus 64. Now let's see if the given satisfies the two conditions. First, we have it is a binomial. So as you can see, it consists of two terms. So that is yes. Each term is a cube. So that is no. Why? So y to the 4th is not a cube. So the given is not a sum of two cubes. Next, example number 3, we have a to the 6th plus 27. So let's see if the given satisfies the two conditions. First, it is a binomial. So it consists of two terms. That is yes. Each term is a cube. So a to the 6th is a perfect cube. 27 is a perfect cube. So that is yes. Now let's have the solution. Cube root of a to the 6th, we have a squared. Cube root of 27 is 3. So now we can write it as the product of a binomial and a trinomial. So the first term is a squared, then the second term is 3. Then we keep the operation plus for the binomial factor. Then for the trinomial, square the first term, we have a squared to the second power, we have a to the 4th. Then the opposite of plus is minus. Multiply the first and the second, so a squared times 3, we have 3a squared. Then the last term is 3 squared is equal to 9. So the factor is the quantity of a squared plus 3 times the quantity of a to the 4th minus 3a squared plus 9. Now let's check if your factor is correct. Given the quantity of a squared plus 3 times the quantity of a to the 4th minus 3a squared plus 9. So cube the first term, we have a squared to the 3rd power. Cube the second term, we have 3 cubed. Then keep the operation plus. So the product is a to the 6 plus 27, or also known as the sum of two cubes or SOTC. So we got it correct. Another way is using distributive property. Given the quantity of a squared plus 3 times the quantity of a to the 4th minus 3a squared plus 9. So distribute a squared to the first term, we have a squared times a to the 4th. Distribute a squared to the second term, we have a squared times the quantity of negative 3a squared. Distribute a squared to the third term, we have a squared times 9. Then distribute 3 to the first term, we have 3 times a to the 4th. Distribute 3 to the second term, we have 3 times the quantity of negative 3a squared. Distribute 3 to the third term, we have 3 times 9. Now let's simplify. A squared times a to the 4th, that is a to the 6th. Next, a squared times the quantity of negative 3a squared, we have negative 3a to the 4th. Next, a squared times 9, we have positive 9a squared. Next, we have 3 times a to the 4th, that is positive 3a to the 4th. Next, 3 times the quantity of negative 3a squared, that is equal to negative 9a squared. And for the last, 3 times 9, we have positive 27. Negative 3a to the 4th plus 3a to the 4th is equal to 0. 9a squared minus 9a squared is equal to 0. So the remaining is a to the 6th plus 27. So we have the same answer and you got it correct. Now let's do more. Factor each completely. First, we have b cubed plus 216. So for the binomial factor, we get the cube root of b cubed, we have b. Cube root of 216 is we have 6. Then we keep the operation plus. For the trinomial factor, we have the opposite of plus is minus. we square the first term, b, we have b squared. Multiply the first and the last, we have b times 6, we have 6b. Then square the last term, we have 6 squared is equal to 36. So the factored form is the quantity of b plus 6 times the quantity of b squared minus 6b plus 36. Next, for number 2, we have 8a cubed minus 125. So for the binomial factor, cube root of 8a cubed, we have 2a. Cube root of 125 is 5. Then we keep the operation minus. Then for the trinomial factor, so the opposite of minus is plus. Square the first term, 2a, we have 4a squared. Then multiply the first and the last, 2a times 5, we have 10a. Then square the last term, 5 squared is equal to 25. So the factored form is the quantity of 2a minus 5 times the quantity of 4a squared plus 10a plus 25. Next, we have number 3, 27m to the 6th plus 512. So cube root of 27m to the 6th is 3m squared. Cube root of 512 is 8. Then we keep the operation plus. Next, for the trinomial factor, the opposite of plus is minus for the middle term. Square the first term, the quantity of 3m squared, that is 9m to the 4th. Then multiply the first and the last, 3m squared times 8, that is 24m squared. Then square the last term, 8 squared, 8 times 8, we have 64. So the factored form is the quantity of 3m squared plus 8 times the quantity of 9m to the 4th minus 24m squared plus 64. Next, number 4, we have a cubed minus 343b cubed. So for the binomial factor, cube root of a cubed is we have a. Then cube root of 343b cubed is 7b. Then we keep the operation minus. Now for the trinomial factor, the opposite of minus is plus. Then square the first term, a, we have a squared. Multiply the first and the last term, we have 8 times 7b, we have 7ab. Then square the last term, we have 49b squared. So the factored form is the quantity of a minus 7b times the quantity of a squared plus 7ab plus 49b squared. And for the last, we have 2p cubed plus 128. Now as you observe, 2 and 128 is not a perfect cube, but we can factor out the greatest common monomial factor, which is 2. So factor out 2, we have the remaining p cubed plus 64. So for the binomial factor, we have cube root of p cubed is p, cube root of 64 is 4. Then we keep the operation plus. Then for the trinomial factor, we have the opposite of plus is minus. Then square the first term, we have p squared. Multiply the first and the last, we have 4p. Then square the second term, we have 4 times 4 is 16. So the factored form is 2 times the quantity of p plus 4 times the quantity of p squared minus 4p plus 16. So let's have the given fraction. So as you can see, 3 is not a perfect cube. So we consider that as the greatest common monomial factor. So factor it out. We have the remaining m cubed minus 1 over 8. Now to get the binomial factor, we're going to have cube root of m cubed. We have m, and cube root of 1 is 1. Then cube root of 8 is 2. Then we keep the operation minus. For the trinomial, that is opposite. Square the first term, we have m squared. Multiply the first and the second, we have 1/2 times m is equal to 1/2 m. Then square the last term, we have 1/2 times 1/2 is equal to 1/4. So the factored form is 3 times the quantity of m minus 1/2 times the quantity of m squared plus 1/2 m plus 1/4. Now it's your turn. Do it yourself. Let's see if you learned something on this video. Factor each completely. Don't forget to comment down below your answer. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!